today we will be discussing this chapter number 4, and in particular we will be discussing our valence electron. As I taught you in the previous video about the atomic structure, so there we have learned about K cell, L cell, M cell. So according to the atomic structure, now you have to take an example of sodium. So sodium's atomic number is 11 and electrons are arranged as 2, 8 and 1 from innermost cell towards the outside. So in the innermost cell we have 2 electrons, that is K cell. Then in the L cell we have 8 electrons, and in the outermost cell we have what? 1 electron. So the number of electrons present in the outermost cell of an atom is known as what? They are known as what? Valence electrons. So you have to remember what? You don't count all the electrons present in an atom. It's only the electrons which are present in the valence cell. Okay, please remember that. In the valence cell or in the outermost cell are known as what? Valence electron. So in case of sodium, from the electronic configuration we see that it has 1 electron in the valence cell here. So this is known as what? Valence electron. Now, valence electron, they are so important. Now they determine most of the chemical properties of an atom. Why? Do you know that? Yes, as I have taught you in class, like for a chemical reaction to take place, there has to be what? Transfer of electron from one atom to the other atom, or saving of electrons. So this brings about a chemical reaction in an atom of the element. Now, you have to remember those elements which have 1, 2 or 3 electrons in the outermost cell or in the valence cell are known as what? They are known to be metals. They are known to be metals. And now they would be acting as what? They would be acting as good reducing agents. So metals will act as good reducing agents. Please remember. Why? Because they have 1, 2 or 3 electrons in the valence cell, so they can easily give its electron, valence electron, to other elements. As a result, they will force others to be reduced. Okay, therefore they act as what? Good reducing agents. Now, those elements which have, say, 4, now this is the second point, 4, 5, 6 or 7 electrons in the valence cell. Now they are generally known to be non-metals. They are generally known to be non-metals. Now this 4, 5, 6 and 7 are the what? Are number of electrons in the valence cell. So if an element has these electrons 4, 5, 6 or 7 electrons in the valence cell, then they are known to be what? They are known to be non-metals. Now, as name itself suggests, they are just the opposite of what? Metals. Now this 1, 2 or 3, they are known as what? Metals, and their properties will be different from non-metals. Now here, these metals are acting as what? Good reducing agents. But non-metals will be acting as what? Good oxidizing agents. Please remember this part, okay? Good oxidizing agents. Why? Because they have, say, usually 5, 6 or 7 electrons in the valence cell. So they gain electron from other atoms of the element. As a result, they will force others to lose electron, and hence in the process it oxidizes the other atoms of the element. So now let's discuss about valency. Okay? So from here itself you can say about the valency. Now for the basic definition, it is what? Valency is the combining capacity of an atom. What does that mean? It means how many electrons are transferred, okay, either lost or gained, or how many electrons are shared by one particular atom. how many electrons. That will give you the valency of the element. Please remember. Okay? So what did I say? I said the number of electrons that are involved in transfer, gain, that could be gain or loss or sharing. The number of electrons that are involved are known as what? Valence. Now usually those elements which have say 1, 2 or 3 electrons in the valence, their valency will be as 1, 2 or 3 according to the number of valence electron in the valence set. Okay? I told you for 1, 2 or 3. Now if they have more than that, that is 4, 5, 6, 7. Okay? Now if they have 4, their valence will be usually, generally 4. Now if they have 5 electrons in the valence set, then their valency will be what? Their valency will be 8 minus 5, that is 3. If it is 6, it is 8 minus 6, it will be 2. And if it is 7, how many electrons does it need to gain to the octet configuration, which is a stable configuration? That is 8 minus 7, that means 1. Their valency would be respectively as shown it is here. You have to subtract from 8 if the electron in the valence exceeds more than 3. Okay? Till 4 it is 1, 2, 3, 4 generally. If it is 5, 6 and 7, you have to subtract it from here. If they have 5, 6 or 7 electrons in the valence, then you need to subtract it from what? 8 to get the valence. Hope this is clear? Now you must be knowing why these elements, atoms of the elements, why do they combine? Why do they react? Why? Because everything in nature wants to be what? They want to be stable. They want to be what? Stable. Even atoms, they are no exception. Even they want to be stable. And I hope you still remember the octet rule and the duplet rule. Octet rule, if an atom of the element has 8 electrons in the valence, then they become very, very stable. And that is known as what? Octet configuration. Noble gases, why didn't I write number 8 over here? Because noble gases, they have what? 8 electrons in the valence, except helium. Therefore, they are what? Highly stable. They do not react at ordinary conditions, atmospheric pressure or the room condition. Okay? So this you have to remember. Now, I told you why these atoms combine. Why? Because they want to gain the octet configuration or duplet configuration. Duplet means 2 electrons in the valence cell. And if it is octet, they want to have 8 electrons in the valence cell. Okay? So hope this is clear. Now, let's discuss this with an example. Since I have shown you the example of sodium over here, let's take this example itself. Okay? So sodium, atomic number 11, it has how many? 2, 8 and 1 electron. And say Cl, it is 70, 2, 8 and 7. Okay? So now sodium, let me take since we are discussing about valence electron, and I told you which electrons are involved in a chemical reaction? The valence electron. Now I am going to write only the valence electron over here. So how many valence electrons are there in sodium? So I am representing it with a dot. Okay? Similarly in chlorine, how many valence electrons are there? 7. So I am representing it as small cross sign. So here, see. Now this sodium, if it loses this 1 electron, then it will have what? 8 electrons, means it will become stable. Therefore, it wants to lose its electrons. Remember that. And chlorine, it has 7 electrons, so it always wants to gain 1 more electron so that it could have 8 electrons in the valence and get the octet configuration. Therefore, this sodium and chlorine, they react. What will happen? This electron transfer will take place from sodium to chlorine. Okay? And as a result, after this what will happen? After this, it will be having 2-8 configuration. After transfer, it will be having 2-8 configuration. After gaining 1 electron, it will be having 2, 8 and 8 electron. Now once it loses 1 electron, it becomes positive. Once it gains 1 electron from sodium, it becomes negative. Now they are highly stable. Why? Because they have achieved octet configuration in the valency. Okay? Therefore, the atoms, they combine. They transfer electron, gain electron, or they combine or share electron so that they can have what? Octet configuration, and they become stable. Now, let's discuss about isotopes. Okay? Isotopes, from the definition, you can tell isotopes are those elements. Isotopes are those elements which have the same atomic number but different mass number. So let me repeat. Isotopes, they have what? Same atomic number but different mass number. So isotopes, they have same atomic number but different mass number. Okay? For example, hydrogen. Hydrogen is, its atomic number is 1. Hydrogen's atomic number is 1. But hydrogen has 3 different mass numbers. In one, it has 1 mass number. In the second case, it has 2 mass number. And in the third case, it has 3 mass number. Now, accordingly, therefore, now this hydrogen has 3 isotopes. So this is protium, this is deuterium, and this is tritium. Okay? Now here, their atomic number is same, means they have the same number of electrons and protons. 1, 1, 1 in all the 3 cases. But their mass number varies because of the changes in the number of neutrons. In this protium, where its mass number is 1, okay, it has a different atomic number. That means it has different number of neutrons. Here also different number of neutrons, and here also different number of neutrons. Now, you have to remember, now in your book you have more examples of isotopes like carbon, isotopes of carbon, carbon 12, 13, 14, isotopes of chlorine, and many more. Now, you have to remember one more thing, that isotopes, they have what? Similar chemical properties. Please remember what? Isotopes, they have similar chemical properties, but they differ in some of the physical properties like melting point, density, etc. Now let's discuss about the uses of isotopes. Isotopes are very, very useful. Okay? And they are very useful in medical or medicinal science. Now remember, the first important use of isotope is what? It is used in radiotherapy. Okay? Like we have cobalt, isotopes of cobalt, that is cobalt 60, mass number 60. Okay, is used in treating cancer. Isotope of iodine is used for the treatment of goiter. Okay, please remember. And we have isotope of carbon, which is used in determining the age of ancient geological objects. And a very well known uranium. Okay, uranium-235, whose mass number is 235, and its atomic number is what? 92, is used as a fuel in nuclear reactors. So I told you about uses. Number 1 was what? Cobalt 60, 27. Number 2, Carbon, which is also known as what? Isotope of carbon, is used for what? It's used for determining age of ancient objects. This is used for treatment of cancer. And similarly, I told you about uranium 235-92 used as a fuel in nuclear reactors. Means when thermal generation of electricity takes place. Okay, and one more use I told you. There's cobalt, carbon, uranium, and iodine. Isotope of iodine is used for the treatment of cancer. So number 4, iodine. Isotope of iodine is used for treatment of waging. So these are a few of the uses of isotopes of different elements. Okay. So with this we come to the end of today's class. Please keep revising these things and practice those structures. Atomic structure from atomic number 1, that is hydrogen, to calcium, as I told you in the previous video. So take care. Thank you.